Let's talk about paradigm shift. It's such a powerful phrase, right? And probably the most used and abused word in our context of technology transformation, organizational transformation. Does anybody know where paradigm shift phrase come from? You do. Here's a little hint. Was this your answer? Oh no, we disagree. Maybe after the talk. Okay, yeah, it goes back to 1962. So Thomas Kuhn, he was an American physicist, historian, philosopher of science, and he came up with a concept in a book that was called The Structure of Scientific Revolutions, and it was a very controversial book at the time. And what he told us what really changed the way we were looking at how science progresses, how ideas move forward. And what he stated in his book was that science progression goes through kind of 4 phases. It starts with normal science, where scientists are just working based on the facts and theories that they already believe and the assumptions that they have. So they're pretty much looking to prove what they know is going to be proven, based on what's already been proven and observed. So there isn't a whole lot of critical thinking going on, in fact, in this phase. And then something happens. We start seeing anomalies. We're seeing things that we can't describe or problems we can't solve within the existing paradigm that we're in. And then we enter this phase of crisis, where we really start doubting all the assumptions that we have built, the current paradigm, the scientific paradigm that we've been in. And that's where scientists start thinking out of the box of the current paradigm. And that's where paradigm shift happens. When we couldn't explain the observations at the subatomic level, we had the paradigm shift from Newtonian mechanics to quantum physics. But what does that have anything to do with data platforms? I guess I'm assuming you're here to talk about data platforms. My name is zhamak. I work for ThoughtWorks as a principal technologist on the west coast of US. I'm based in San Francisco. I work with a lot of clients that are building their next generation data platform right now. I also sit on our tech advisory board. We publish Tech Radar, so we see a lot of projects across the globe. And I can tell you we are seeing a lot of anomalies. We are seeing large investments in next generation data platforms that are not really successful. Best success rate that I can tell you for a company being data driven is about 60%. At best, the data platforms that are being built are used in pockets for research, R&D, data analytics, but in R&D form. There's a lot of friction between the teams. I actually started a mail thread on our software development mail list a little while ago, failure modes of data lake, and it created the most lively conversation across the company. And I'm personally in that crisis phase of Kuhnian revolution or paradigm shift. I feel that the paradigms that we have, the assumptions that we have in how we should build data platforms, it's not solving our problems. It doesn't scale. So what I want to tell you is what's the state of the art that we see right now, people building data platforms? What are these anomalies and the problems? And what's the paradigm shift, in my opinion, and a few of my colleagues. And I call this talk a success if I can make you a little bit uncomfortable, if I can get you to start doubting some of the assumptions that we've built so far in terms of building data platform. So forgive me if you leave this talk with a little bit of uncomfort, but I want to nudge you to start doubting and start questioning. So what is the current state? At a 50,000 feet view, this is the data platform architecture of many organizations we work with. It's a centralized piece of architecture that is responsible for ingesting data from different sources within the organization or outside of the organization, from different domains and operational systems. I'm going to use retail example quite a bit because we're all familiar with retail. It's easy to understand. So you might have your click stream coming from your e-commerce systems, orders fulfilled through your order management, sales, and you get this kind of large number of sources coming into this platform. It's a centralized platform that is responsible for kind of making sense of that data, cleansing it, preparing it, and then providing it to consumers. And consumers might be in different categories. You might have analytical consumers where data scientists are just exploring what the data means and getting some insights out of it. You might have BI reporting, your sales and financial reporting coming out of it. Or you might have operational systems that operationalize, a recommendation machine learning machine that needs to feed the data for training or feed the data for actual scoring and recommendations. Let's go to 30,000 feet view and look inside the data platform. The architecture within the data platform is very much functionally divided. So you've got services and you've got this pipeline structure as a dominant architectural structure with phases that ingest data. They get the data, they cleanse it, they make sense of it, maybe opportunistically enrich it with other data. They aggregate it, form views that are relevant to consumers, and then have the data served to the consumers. So very much functionally divided, a pipeline. You might get data from streams, ETLs, or God forbid going to somebody's database and getting the data, internal data out, and serving it in other forms of APIs or other forms of data stores. And if we go to 10,000 feet view and look at the life of the people, on one side you've got the developers that are building the operational systems, that are providing the source data. They rather have a good life. They're somewhat oblivious to the data that they're providing, whether it's truthful, whether it's correct. They don't see where the data is being used and how it impacts their system so much. So you've got the developers that are providing the source. Probably the data engineers in the middle have the toughest life, hence the sad face. They have no clue really what the data is about because they don't belong to the domains where the source comes from. They don't belong to the consumer domains that are using them. They have to make sense of it. They have to, clean it and respond to both ends. So they're pretty much siloed in the middle with domain agnostic skills. And on the right-hand side, you've got this kind of frustrated data scientists or BI teams or operational people because every change they need, any new piece of signal that they need to get, they have to ask the data engineers or data platform to give them. So it becomes this competition of who's going to get their requirement on the top of the backlog. Does this resonate with anybody in the room? Yay, a few hands. Do we have data engineers, sad face, people who are working in the data engineering space? Oh, 1, 2, a few. And people who are providing data or consuming them, sit on the either side. Yeah, we've got a few people. So I'm not too off the track, I guess. What's wrong with this picture? Any ideas? So let's start with the life of people, right? For the first part, we've got this siloed, hyper-specialized group of people that are put together away from where the domain knowledge exists. So we've got hyper-specialized data and recently the new shiny title of ML engineers kind of doing the automation. They're not only segmented like organizationally, but their skill set is also very segmented. The skill set that they bring to the table is very much automation of the data engineering practices. And on the other side, you have, on the operational world, I think we figured it out. I'm sure you've gone to a lot of microservices talk in this conference, and we figured out, cross-functional teams oriented around domains, happy teams, kind of self-sustaining teams. So this siloed hyper-specialization, we have seen this in the past. Do you recall this in the last decade? A wall that we used to have? What was it? Developers and operation people. So we had that wall, right? Ops were hyper-specialized on how to run the systems, and devs were hyper-specialized how to build. Neither of them had any clue. Devs didn't know how to run their systems, and ops didn't know how to build or how to fix if problems happened. And we fixed that problem. We fixed that with the paradigm shift of DevOps. We put the people together. We cross-pollinated skills. We architecturally, organizationally, culturally changed everything. And a very nice side effect, apart from having happy teams that could work together and remove that friction between them, but one other nice side effect happens. New disciplines and new groups of people, like the SRE engineers that we have today, site reliability engineers, these are the people that by cross-pollinating developers and operations, they learned from each other and they crossed to the other side. Operation people started adopting software engineering practices, engineers started understanding operations. I work with a lot of colleagues that used to be purely software devs, and now they're SRE or DevOps engineers, whatever the title of the day. The second problem is this functional division. And what do I mean by that? So when we looked at that big giant architecture, as the platform grows, as the consumers and producers grow, we have to break it up somehow, right? We have to break up the architecture and break up the teams around it. And what I've seen really actually successful tech giants in Silicon Valley doing is they breaking this analytics group and their architecture based on these phases. So they've got like ingestion teams that are just ingesting data, they've got cleansing, then they've got aggregation teams, and they've just got this technical functional division. And if you tilt your head 90 degrees, we have had technical, functionally divided architectures in the past that didn't work. So we had, the architecture of the early 2000s where you had your UI teams, a UI layer, you had your business logic services, you have your DBAs and database layer across your kind of large-scale architecture. And it really didn't work, and it didn't scale. I have a little litmus test for you to know whether, if you're building a data pipeline, if you have a functionally divided architecture. If I ask you go to whiteboard, and I do that with a lot of our data engineers, and say, can you draw me your architecture? If you end up with a bunch of pipes and databases maybe hanging off them, and that's what you draw, you are thinking functionally about the structure of the architecture. Not about the domain, the actual data that needs to change and lives in there. And the problem with this functional division is that it's not designed according to the axis of change. And let me describe this. So if you have, let's go with an example. If you're a Spotify or SoundCloud and you're interested, and what you're publishing is the artist albums and songs, and you're interested in your listeners' behavior. What songs do they like most? What do they listen in the morning, in the afternoon? The events happened, what do they listen in the events? So we can make story of their behavior. And right now, for instance, Spotify now supports podcasts, you support events, so you're supporting these new features, right? So we want to know how podcast listeners behave. What do you have to do to introduce that end-to-end feature to your data platform so you can get those signals about your podcast listeners? You've got to go talk to that team, build the ingestion services, and then talk to the second team, building whatever correlation enrichment they need to do at the session, user session to the data, add to aggregation team that are trying to make the life cycle of the user behavior out of that. So essentially, you have to synchronize work across 3 different functions to get one end-to-end feature. So this architecture is not built around axis of change, so you can, kind of localize change to one group and one team. And this was the problem of the previous layered architecture. Does anybody live in this world? That every time you need to have a new feature, you've got to go with different teams. Some heads are nodding, a hand going up. So axis of change and architecture around that is an interesting kind of concept. And lastly, I'm going to stop complaining. I promise. This is my, I think it's the last slide that I complain. It's centralized and conflated. By centralized I mean that my colorful, squiggly blobs are domains. So the concept of this is a customer, this is an order, this is an e-commerce interaction, this is an in-store interaction. Those rich concepts are all kind of centralized in one domain agnostic piece of architecture, and is conflating two different kind of disciplines. It's conflating the data, the actual content that we care about, with the infrastructure that is going to support it. So the infrastructure that runs the Spark jobs, store the data, and so on. And it's all conflated in one data platform. And we've seen that in the past, right? We tried to escape the monolithic kind of attack in the last 10 years, and we've done a good job in the operational systems. And for some reason, for big data, we accept that monolithic. So let's recap. Hyper-specialized teams, building, operating, centralized pipelines that are built around kind of implementation functions, implementation details. And this doesn't scale. And this is the anomaly that we see. That's what happens when you don't sleep the night before. So to prove my point, the friction points, the tension points that breaks the system, two things. Ubiquitous data and your innovation agenda. So the more and more you turn on these sources, these yellow and red boxes on the left-hand side, you're going to put more tension on that centralized piece of architecture. Imagine a retailer, I work with a retailer, they have multiple brands, they globally sell those brands, they sell them through different channels, online and in-store and franchisees, and they want to get data about all of this information globally in the data platform, in the one place that all this data goes through. So that centralized piece is really not going to scale as your left-hand side scale. And we know that companies are moving faster and faster. So we are talking about introducing, companies adopting test and learn culture, where you're testing continuously different features and, try them out and retire them or adopt them. And that creates that consumer proliferation, where you have more and more demand from the consumers for wonderful ways of combining and stitching the data. So these two friction points really going to break the system. I meant to go that way, not the other way. But the curious thing is that we have seen this architecture before in the data space. Although we have new shiny names for all these cloud-based tools that we're using, we have Azure Data Factory, and we've got Kafka and all that sort of stuff. But if you look back at the data warehousing era and that architecture that failed, it actually looked exactly like this. So I I asked for permission from my colleague Ken Collier, who wrote Agile Analytics, that picture above, which shows the before of the modern data platforms and how you've got the source systems and ETL jobs and integration presentation. And that's exactly what obfuscated, so you can't really see, but that diagram from one of my clients right now building a large enterprise data platform is exactly the same as that. It just has new names in terms of tools. So we've changed our tool set, we haven't changed our mindset. And a little justification. So I know I complained a lot, but there is a reason that we are here. We keep repeating these paradigms. And does anybody have an opinion why? Like we've done it with data warehousing, we did it with self-managed Hadoop clusters, now we're doing it with whatever the next generation data platform is. Why we're repeating the same patterns? Any hypotheses? Yes?
I think maybe we are comfortable with it. We are used to it. Comfortable with
Yeah. I agree, and I think actually, like if you think about the S-curve of our industry growth, like the data space growth, I think that we are very early in that maturity and growth curve. When you look at a lot of companies, they're building a lot of platform, but they're not really using them. They're hoping that these wonderful use cases will emerge, and we will let's just get the data in there, and we will, make use of it. But we haven't really used it. So when you are at the beginning of a curve of maturity, you very much optimize locally. You optimize locally for a small group of people. So I'm optimizing for my data engineers. I'm optimizing just within that platform, and optimizing for now. As you grow, a lot of enterprises, when they grow, they try to optimize globally for their solution, and that has its own problems. They optimize for all the possible future cases and optimize for all the people that might come and use the system. So we're not at that optimal place to how to optimize for a cross-function team, for continuously increasing number of consumers. So we are fairly early on in that S-curve of growth. So what is beyond the lake?
Just let me add something there.
Oh, sure, go ahead.
I think that this early stage is not only for data, I think it's for software engineering. If you look at engineering in other fields, it has been for hundreds of years. And now here we are only with a few years, and we're repeating and repeating and repeating, and we don't learn what had happened in the past, and we're repeating and repeating all the time.
Yeah, I agree. For the last six...
And it's easy and cheap to repeat, to recreate everything.
Yes, we're comfortable with what we know. Even though it didn't work, we're just comfortable with what we know. I agree, but what made me curious to kind of put my nose, I guess, in this space, for the last 7 years, I've been working very closely with our clients building microservices. I've been writing about it, I've been talking about it. And I feel like in the operational space, we saw a sudden kind of acceleration of tools and mindsets and domain-driven design, microservices, like how to build these cross-functional teams. And there were a lot of movements and changes that really unshackled the companies to move faster. But when it comes to data, and I read a lot of mail threads between our data engineers internally, and the questions they ask, the concerns that they ask, this is just basic good engineering or bad software engineering. I don't know why we threw out all the basics of good software engineering when it came to data, because it's hard, it's very sticky, right? We view the data as this sticky glue that everything stitches together, and it's hard to do the division. So I have to confess, I don't have a name for Beyond the Lake. It's mysterious enough to be appropriate for now, but if by the end of the talk you have a better name, please come and talk to me about it. So, we talk about the Kuhnian kind of scientific revolution and this concept of paradigm shift. In 2011, 12 MIT scientists wrote a white paper, and they decided that the next Kuhnian paradigm shift is going to be convergence. So convergence of physical science, life sciences, and engineering, and doing science completely differently. And I think the solution for Beyond the Lake is the convergence of data, domain-driven design, product thinking, and platform thinking and building platforms. I put all the buzzwords that are currently out there on this slide for you, but there is a point behind it. So there are good examples of convergence that has happened recently within our own field, software engineering. I wonder if you can recall. People have been talking about it in this conference. Any suggestions? Convergence on two fields, creating magic in between. Okay, so Neil Ford and Rebecca Parsons, my coworkers, they created the idea of the concept of evolutionary architecture. Anybody familiar with evolutionary architecture? Yeah, a few people. So they brought in natural evolution theory to, algorithms, computer science with genetic algorithms, and then mixing that with architecture and defining a new way of, making sure your architecture going through the right direction. So it's been done. And it works. So let me take you through the convergence between these and our thinking around data. So who's familiar with Eric Evans' domain-driven design? I expect all hands to go up. Okay, just a few didn't. So just a quick recap. So Eric Evans really fundamentally changed the way we design software. So he argued that it's best to mirror our software and the technical assets with what the business represents and what the business uses in terms of language, in terms of how businesses structure itself. And in my opinion, there are parts of architecture that are science, getting consensus protocols and Gaussian protocols and CAP theorem and all that sort of stuff, fits into the science bucket. And there's part of the architecture that is kind of art. And it's hard to define it. So Eric Evans' domain-driven design really solved that arty part of architecture, that how do you break up your systems? And the way we are now breaking up our systems are around domain concepts. So with your different business units and business kind of domain boundaries replicate, your system and services replicate that. So what does that have to do anything with data? I think we need to kind of start creating and reifying those domain concepts out of this big blob of big data platform that we have. We need to push the data back to the domains where they belong. So if I'm in an e-commerce domain or a commerce domain and I'm interacting with the customer and I have the information about the click stream, I should be the owner and responsible person who's capturing those events, who's producing those events, to provide the data, the truthful, trustworthy, clean data for that domain. If I'm in, on the other side, the pink and kind of purple side, the consumer side, and I'm expecting, data that I'm working on, let's say a recommendation system, and I need to aggregate data from different places. And that aggregated view might be an interesting view for other people to use. So I should be providing that data, building that data and providing it to other domains. So pushing the data back to where they belong, the domains that either need to produce them to consume or produce them as facts of business for other people. And I think this idea of ownership is really key here for the domains, because they're in the most suitable, optimal place to give you the data that is truthful. I love this word, REIFIED. James Lewis, who talked first about microservices, used it in the concept of microservices that are things that are abstract, like configurations, make them concrete. And we have to make the data, domain data, concrete and back to where they belong. We have to do something about that centralized big data pipeline. We've got to distribute it. It's got to go back to be not the primary concern, the secondary concern, and implementation detail to those domains. So if you think about those cleansing and preparation tasks that happens as part of the ingestions, well, who is best positioned to cleanse the data and give you meaningful data? Well, the people who are producing it, right? The source system. So those cleansing jobs kind of go back to those source domains, and providing aggregate views that are relevant are going back to the consumer side. And really, what I want to really emphasize on is that domain is the primary concern. Pipeline is just an implementation details that we want to hide. Pipeline is it's an implementation detail that shouldn't be the primary concern. And we did that with microservices, right? So we said the first concept is the service and the domain, the bounded context. The layers of UI, business database, those are implementation details that we really don't care about. We shouldn't care about so much. The team who's working on it will care about it. And finally, secondly, let's talk about product thinking. So this idea of applying product management techniques and approaches to our technical assets have been very successful and popular in the last few years. Any product managers or technical product owners in the room? Yeah, we have a few people here. So as you know, we have started treating our internal technical assets as product. What does that mean? That means we care about the developers who are internally use them. Like let's take APIs as an example. If you're building internal APIs, you probably have a product owner for it. We assign KPIs or net promoter scores. Who's using our APIs? What is the rate of adoptions? We really treat it as a product, and our primary concern is the experience of the developers. In case of data, the data scientists, the machine learning engineers that are consuming that data. And that's been super successful. So while we push this domain data back to the domains, we need to treat it as a product. Just opening up your database, which is your internal database, to somebody to run an ATL job, that's not going to create the best developer experience. So I've talked to a lot of data scientists, and I've asked them as an archetype of, consumer or customers of the data, what do you care about? And the things they care about is really not where this data comes from, who owns it. What they care about is they want a data that's discoverable. They want to go to a registry, see what is all the data that we have in the organization. What's the address of it? How can I get to it? They want to see that it's addressable. They care about that they can trust it. They can trust the data they're going to use, and they're not going to find anomalies that they can't explain. They can make sense of it. It's self-describing. It has a schema available to describe what the data is. It has good documentation to describe the data. And finally, it's interoperable. So it has, it's governed by some global governance in terms of some of the conventions that we use. so that they can stitch data together. So if you're identifying, let's say, your customer, you have a certain pattern to identify your customer, you probably want to have that globally known pattern or customer ID as something that is part of your global governance, and everybody use that schema so that you can identify the customer across domains. That's some of the examples. And what they also care about is that it doesn't really matter if you're producing data as a stream. So let's say you're in the e-commerce system and the click stream is coming out as streams, or you're providing historical data. So you have a big data storage that has snapshots of the historical data. Both of those should have these properties. And now that we've created these data domains as products, we need to have and we've actually asked this domain people, go and build your data pipelines, so they need to have cross-functional teams, and their skills need to be augmented with data engineers and product owners. And did you see what I just did that up there? They're happy, yeah. So they have the right set of skills, and they can kind of work together to hide the complexity from the rest of the organization and provide nice, clean, trustworthy data out of their domains. But the question that I often get asked is, so you mean that all of our teams need to go and now build the full stack big data infrastructure to run their data pipelines? That duplication is not really acceptable, right? And we don't really mean that. So in the last few years, like every conversation I'm part of, I always hear the word platform. Does anybody have a good definition for a platform that they want to share? I'm really curious. It's one of those words, right? So to me, platform is a piece of your architecture or infrastructure that hides complexity from its users, is provide a capability with some level of abstractions, and it's most importantly can be used in a self-serve manner. So in terms of the data pipeline, if you have part of the pipeline which is about, I want to just write some Spark jobs in my Git repo, and I want them to run magically. The infrastructure that supports running those jobs and providing the results and so on, that should be part of the platform. And as a team, I should be able to just simply use it. Let's say there are templates that I can use for cleansing and running cleansing jobs, that should be part of this platform. So we end up pushing the domain agnostic kind of features that they were sprinkled around that. Remember, I used the word kind of conflated data platform into the data infrastructure as a platform. A great example of that is Netflix Metaflow. Has anybody worked? I mean, it's not. I don't think they have open sourced it yet, but has anybody seen? It's a fantastic ML. Definitely go and look up the talks just as an inspiration. So what they've done is they have this fantastic kind of data infrastructure, they call it MLOps, that sits on top of their very well integrated infrastructure. And at the top, you can simply, as a data scientist or data engineer, write step functions, they call it, Python scripts that can descriptively put annotations, say, this data comes from that S3 bucket. I want it run to machines of that power, with that capacity. So you can very easily just write a bunch of Python scripts that would run as containers. They collect the data, they do all the different steps, and the interim steps data gets stored. And finally, that data can be provided as APIs with a few lines of code in Python. It's really magic how they've built it. And they've built it obviously on the different layers. They had the Meson layer, which is their Airflow workflow management, and underneath it they have Titus, which is their Kubernetes, the container management. But that level of sophistication into the platform that you can just write a few Python scripts and you have a pipeline. It's really magic. That platform thinking or building platform can give us. So let's recap this thing that I don't have a name for. Cross-functional teams, they're oriented around business domains, and they're serving data as a product. And yes, internally, they might have a pipeline. That's OK as an implementation. And they're using a data infrastructure as a platform. What does it look like? Beautiful. I mean, my 5-year-old painting is not that great, but it's really a graph, right? It's a graph of really domain-oriented. You've got these interfaces where your interface might be just a URL to your S3 bucket, right? With a schema definition and documentation around it. It's not that magic. That they are communicating data, the internal dependencies on the data platform, and happy teams. I've missed some, and then the governance piece is really important, and that's the topic of a whole other talk, that what do we need to standardize, what do we need to diversify, and in terms of data interoperability, there are pieces that we need to standardize. I've missed something in this picture, I just found out. I wonder if anybody spots it. Yeah? They're all consumers and producers. It's a graph, right? So anybody can be both a consumer, both a provider. Sorry that it didn't come across. I've been using this color coding as purple being a consumer. But it's really, we have to think about, I love graphs because it's such a scalable and elastic structure. It's like the universally true structure that you can kind of use. But it's really, we're talking about a graph that you can stitch and aggregate data from different domains. What I forgot to draw was some gray people down the bottom, because that data platform needs an ownership, and that needs to have skill set that data ops people have, and they would provide that platform. And that's kind of domain agnostic to a degree. How do we get there? I have shared a few obvious examples in terms of moving, distributing the pipelines, forming the teams, data as a product. But I share an anti-pattern with you, how not to get there. And this is a phrase that I continuously hear. A lot of the CTOs and CIOs, they say, we know what the good looks like. But to get there, we're going to have to get all this data in that one place, in that data platform. And that shouldn't be the first step. Without having consumers, without having real cases, real business cases to build upon, yes, we're going to spend a lot of time to get this data into data platform without really getting any results. There is an interesting model that a colleague of mine, Dinker Chark, and I got the link down the bottom, shared from a work that we did with a really large private bank. And they wanted to build a data platform. Yes, there is some traditional data platform elements to that, but he called this, what I really liked about this approach, he called it HOURGLASS. He started building the data platform to actually talking to the CEO and the C-level kind of executive at the company and say, what do you want to get out of data? In a private bank, what is the capability that you want to get? I'm not going to go, it was actually quite interesting to learn about private banking and what are they called? High-value networked individuals, people with many accounts and many families at the same time, and they're managing this big global business. Not going to go there, but to satisfy the experience of those, they came up with a few use cases. They came up with kind of even funding models. So they kind of started with couple of use cases from the consumer cases that they had, and then they said, okay, what are the common data sources that we need to pick? And they started forming this hourglass from going from the consumers. And in a span of 9 months, they've kind of enabled quite a bit of capability across this kind of tilted hourglass. I love this quote by Pierre Abelard, a French philosopher. By doubting, we are led to question, and by questioning, we get to truth. And hopefully in this talk, I just nudged you a little bit to question if you come across one of these monolithic data platforms, silo teams of data engineers, pipelines as the first-class concept. And we start a movement. We start the next paradigm shift. And I have to say, this is not all theory. So we are using this model at a car retail company in Germany. I was really excited. I talked to one of the head of the analytics for a really large tech firm in Silicon Valley, and he said to me, you got my wheels turning, and maybe I change my architecture overnight, but I will not change my teams and my organization overnight. So changing his teams according to this model, it was something that was difficult. You don't want to move people around overnight, right? And then I heard back from our team on that client last week that he just announced in an all-hands meeting that they're restructuring their teams around these domains. I'm getting goosebumps right now. So that was kind of, I guess, encouraging. So it's not all theory. Thank you very much. Oh, this jumped out. A couple of little asks. There is apparently a judgment machine at the end that you can kind of judge my talk. And if you're interested to do this sort of work, ThoughtWorks also has a booth upstairs. I think it's upstairs to come and have a chat. Thank you. And if you have time, I'm happy to take questions. I have time? If there are any questions, I'm happy to hang around and let's go ahead.
Yeah, well, the past I've tried to do sort of things like
Sure.
putting teams that are in charge of different functions together, domains together in a kind of master data management oriented application development works fine. My problem is when you have common domains like user, for instance, that I use across different domains, I cannot solve the problem putting the information in different places without duplicating the information. When I duplicate information, then I get in a big trouble because then I have to have consistent information in all of these different places, and then I make people sad. So I think it's a compromise between putting things in different places, but at the same time having a common hub, I don't know how to call it.
So two things to that. I think having a common hub, if you're just starting and you're smaller and you don't have that problem of scale, first of all, it's fine as a starting place. Second, I would say the reason, if we go back to the business truthfulness, like if your domain is truly reflecting what that business does, what aspect of customer should belong to this domain and what aspect should not belong to this domain, should not be duplicated here, should belong into another domain. So at the source level, we probably won't have so much duplication, because if I have a domain that is around interaction of the customer in the stores, let's say, and I have a domain interaction of the customer around online, there isn't much overlap there. However, there is an aggregated view that needs to be created, right? Data needs to be stitched together to make a meaningful ghost views. Oh, okay. Ghost views of my me as a customer as one entity, and creating those as their own domain. So you may bring domains into existence that they did not exist before, just for the sake of aggregation of meaningful data, not into one, but into their own domain. Hopefully that helps. Yeah. But I understand the dilemma. Yeah.
Could you elaborate please on your slide with the graphs? So there is some products, services exposed to some kind of interfaces, and we have line between them, right? And we call it graph. Would you elaborate?
Yeah, sure. So I guess what I was saying is that if you zoom out to the really, really big picture, if you have, let's say, an order management team that takes care of the orders, that they say, we can publish events. For every order that fulfills or failed, we publish events, order fulfilled information about that events. And we provide you an indefinite kind of stream of events as an interface that you can come as a consumer, you can find it, you can address it, you can use it. That interface might be just a Kafka topic, interface with schemas and information as what the data is in it. So the little lollipops were just as addressable endpoints. They may be just a topic on a Kafka stream. They might be a S3 bucket, but they're addressable, and people can find them to get the data and query the data the way that makes sense to that interface. What I was trying to show with the graph is that at the end of the day, it's all about stitching data together. And this data might come from different interfaces at different places. And when it gets stitched together, I hear this phrase quite often, optimistically enrich while you have the data. Don't duplicate this enrichment, or optimistically aggregate. Sorry, opportunistically aggregate. So when I have the opportunity of like getting data from different places, I might as well, because I want to opportunistically stitch it together, provide that as data to other people, so serve that. So the connection was just stitching data from different places together, being able to reach out to any place. And technically, it might be writing a pipeline that reads from 3 different Kafka streams, merge them together, has some sort of a Spark, let's say, stream process that merges together, put it in a store, and maybe that store can be exposed as another data. On the top, I had the governance. It was just a logical. Yes, clear. Sorry.
So does it mean that you have multiple stores, that you hide it over some kind of service interface, whatever? Right? Now, if you really need analytics, right?
Yeah.
You have some kind of abstraction layer to go to each store and get the data to stitch it. How would it work?
So if you are, let's say you're writing, so what you're just writing let's say you're writing a stream and you're getting data from different streams, all you need is some piece of software code that reads data from 3 different Kinesis streams, and it gets the data in memory, maybe puts it in a disk, a storage in a minute. So that's technical implementation of just reading, or if it's in a database, it might just go through a database, the table that is allocated, or a set of files on the S3 that is allocated as the data. So it's not necessarily a RESTful API endpoint. Oh, sorry.
I work in big bank, right? So, and we have, let's say, trading system, ledgers, customer information, right? So I like the idea to have this cross-functional teams which owns the data, right? But now, when we need a data lineage, for example, to satisfy some regulatory requirements, right?
Yes.
We need to get data from all these systems, right? How would I do it?
In what way?
In what way? How would we? It's not a runtime interface or events, right?
So
I need a massive amount of data for all these systems, right? To close the data.
So what is the right now, for instance, what is the storage that you're using for a large amount of historical data? It won't be any different from that. So the data, to access the data, it would be just going to, like any storage that you have today, it would be just reading from that storage data. It's not any different from what you're doing right now.
To stitch the data, you need kind of an abstraction layer, right? To be smart enough to go and get the data from here, from here, from here.
Yeah, and that's the code that you write. I think that's the code that people would write to do that. That's custom software delivery with support of the libraries, I would say.
Thank you.
And come and talk to us about that if you get there.